right? So the next thing that you need to know in indexing is like secondary index. So why do we go for secondary index? So in the case of sparse indexing, so as the size of the table grows, the size of the mapping also grows, right? So when the size of the table is going to increase or it's scalable, the size of the mapping also is has to be scaled. So generally the mapping is usually kept in the primary memory so that the address can be fetched easier and faster, and the secondary memory searches the actual data on the address got from mapping, right? So if the mapping size grows, then fetching the address itself becomes slower, right? So in this case, the sparse index will not be efficient. To overcome this, a secondary indexing is being introduced, right? So usually the mappings are kept in the primary memory so that we'll be able to retrieve the records very faster. However, when there is a scalability in data, right? When the secondary memory, when the searches the actual data based on the address from the mapping, if the mapping size grows, then fetching the address becomes very slower. So in this case, sparse index will not be efficient. So let us see how secondary indexing techniques work, right? So in the case of secondary indexing, to reduce the size of mapping, another level of indexing is introduced, right? So, so the mapping in the first level is stored in the primary memory so that the address is fetched faster, and the mapping at the next level is stored in the secondary memory, right? So by this way, you will be able to address the scalability issues, right? So you have two types of mapping. So the mapping at the first level is done in the primary memory, and the mapping at the second level is done in the secondary memory or in the hard disk, right? So in secondary indexing, to reduce the size of the mapping, another level of indexing is introduced, right? So in this method, a huge range for the column is selected initially so that the mapping size of the first level becomes small, right? So let us see an example for a secondary index, right? So secondary index, the first level of mapping is done in the primary memory, and the second level of indexing is done in the secondary storage device, right? So first level is going to be like, for example, maybe 100. It's a sparse index, 100, 200, 300. So the information about the records 100, 200, and 300 are available in the primary memory, right? So it also contains the pointer to the particular location of the record, right? So the primary index is created first, followed by the secondary index. So the secondary index is stored in the hard disk, and it contains the location of the data block in the memory, right? So by this way, you will be able to uh, save a lot of space in the main memory, right? So the idea behind secondary index is that you have two types of indexing. So primary index is stored in the main memory, and the secondary index is stored in the hard disk, right? So whenever you need to retrieve a data block in your memory, first we look for the particular index in the primary memory, which is a sparse index. From primary level index, we'll move on to the secondary level index, and then finally we'll be able to access the data in the memory, right? So this is about secondary index.